Hello guys, I'm here to present to you the fixed point method. So let's begin. Well, fixed point method goes as follows. Let's say we have an equation, for example, this one, and we want to solve it. Okay, the function that represents this equation is the following. We just uh, write this expression. And of course, we want to find the value of x, which satisfies that this function, when we evaluate it at x, is equal to 0, of course. So the fixed point method is very simple. All we have to do is find an equivalent form of this equation. For example, we can write with respect to x. Of course, now you could argue that, for example, in this equation, which we want to solve in particular, there are many ways to solve with respect to x. And as we will discuss later, there are many ways, but some of them do not lead to what we call convergence. I mean, we can now solve with respect to x. For example, x is equal to this expression, and this expression in particular, is uh, this plays the role of this function. Of course, you could argue that you could have done something alternative. For example, you could say minus x is equal to the natural logarithm of x. So x is equal to minus the natural logarithm of x. And this could be used as g. But what you will come to realize is that this function, this choice, does not lead to what we call convergent behavior. For example, what we want to show is that if we choose wisely our initial approximation of the root, we want to achieve the following um, the following goal, starting with this as our first attempt. We will compute through this evaluation. We will compute our next um, approximation, and as we continue this procedure, we eventually wish to approximate our holy grail, our root. This procedure does not always lead to success. Let's. It's very easy to implement this method in a computational framework, for example, by using Octave, which is, as you all know, also free and very easily accessible by everyone. Thank you, Octave. So let's say our let's create first our function. G is equal to um, this expression. You can see that I use this function functional. This is called function handle. I'm sorry. Excuse my poor English because I haven't used them in a while. So we set our initial value to be equal to 0. And look now how the method is implemented. Then our next approximation of x is equal to 1, of course. We repeat this procedure. Look, as we do this multiple times, we eventually witness that the values begin to to approximate a specific value. That's not by chance. For example, if you had implemented the original equation in Octave, which is this one, and you had used the you know um, the tool of Octave, which is called fsolve, to solve it numerically without actually programming anything, you would choose here an initial approximation, for example, 1, and look, it gives you right away the correct solution, numerically, of course. Okay, so of course this would be a little more challenging to do it with, you know, a normal calculator. I mean, without using any specific uh, tools that modern calculators have, which actually make it possible to solve even more complex problems, of course, as I'm sure you already know. But what my goal was here is to show to you that how to actually perform this procedure, the way how you choose to implement it, and in which program, it's your choice. So, in order to address the previous remark they made, if I had chosen to use as G, this expression, G would be equal to minus natural logarithm of x. Okay, and let's set x be equal to not 0, because you immediately see the problem here. You cannot set x to be equal to 0, but let's set it, for example, 2. Okay, okay. So we begin. Why don't we try the previous procedure? Look, we cannot arrive by any means to our root. So there you go. I think you have a pretty good grasp of the method. But I've used this example many times because I think it is a very easy way to demonstrate the basics of this method. So I hope you find this video useful, and see you next time. Thank you. Of course, if you could perhaps address the comment section any particular problems that you would find interesting. I cover certain topics in engineering and in and in the science in general. By science, I mean problems in physics, mathematics, chemistry. I have a pretty wide range, so let me know. Thank you. Have a nice day.